Hi, welcome to my video on rational expressions in functional notation. So this video is going to talk about functional notation. Recall functional notation in the form of f of x, g of x, h of x. So functional notation is this form. It replaces the y in the equation. Let's do some examples. Y equals 2x plus 3. If x is 4, then you put 4 in the place of x in the equation, and you get 8 plus 3, which gives you 11. So similar to that, if you let y equal f of x, so the f of x and the y are acting the same, they're equal to each other. The f of x is the y value. So what happens, I got the f of x equals 2x plus 3. I'm looking for the f of 4. When I say the f of x and the f of 4, that means I'm saying that x is 4. Note, x is 4. So I put 4 in the place of x in the equation, and I get 8 plus 3, 11. Notice I'm doing the two of them, showing you that this is the same as this, only this is f, this is y equals, this is f of x equals. Let's do some more examples. The g of x is x squared. So this is the g of 6. So that means x is 6. So you put 6 in the equation and square it. 6 times 6 is 36. So again, y equals x squared, and we got x is 6. So that means y equals 6 squared, and that's 36. Make that a 6. So what we're saying is that the y and the g of x are acting as they're the same. So don't get confused. If you see f of x, g of x, p of x, that's the y value in your equation. And the reverse of that, if y equals 2x plus 3 and y equals 23, find x. Both of these are y's. That means that 2x plus 3 must be equal to 23. Since that's a y and a y, and the y's are equal to each other, 2x plus 3 must equal 23. So solve it out. 2x equals 23 minus 3. 2x equals 20. Divide by 2, and I get x is 10. So that's the same as here. So again, check. This equation, same as this one. This equation, same as this one. Why? Because the f of x is the y. The f of x is your y. So if you have these two equations, and f of x is here twice, it must mean that 2x plus 3 must be 23. So they're asking you here to find the value of x. So it's the same equation, and you get x is 10. So the f of 10, see? So if you find the answer is 10. So the f of 10 is 2 times 10 plus 3. So that's 20 plus 3 gives you 23. So again, the two of these are equal, so 2x plus 3 must equal 23. So the f of x is the same as y's. In this equation, I got y equals x squared plus x minus 6. Y equals 14. That means that x squared plus x minus 6 it must be equal to 14, but they're both equal to y. We got a quadratic, so let's move all terms to the left side. X squared plus 6, x squared plus x, subtract 20 equals 0. Quadratic, two factors. X squared is x and x. Factors of 20 to give you 1 are 5 and 4. It has to be a positive 5, negative 4, but the product is negative 20. Sum is 1. So x plus 5 equals 0, or x minus 4 equals 0. X is negative 5, x is 4. And so this is the same, not the same as this equation, but if you got f of x equals x squared minus 4, and you got f of x equals negative 3, both of them are equal to f of x, so x squared minus 4x must equal negative 3, because they're both equal to f of x. That means x squared minus 4x plus 3 equals 0. Because it's quadratic, everything moves to the left side in descending order. That's factorable as x and x. 3 is factors of 3 are 3 and 1. Because the product is positive and the sum is negative, must be two negatives. So x minus 3 equals 0, or x minus 1 equals 0. X is 3, or x is 1. So let's continue. Let's continue. Find each in simplest rational form or fractional form. If the f of x equals 2x plus 3, then the f of 1 over x. So that means I have to put a 1 over x into the place of x. So I simplify this as 2 times 1 over x is 2 over x plus 3. The common denominator is x. So we multiply 3 over 1 by x over x. That gives us 2 over x plus 3x over x. Notice the common denominator is x, so we add. We get 3x plus 2. So when I sub in 1 over x in the place of x, I have to simplify this, and I need common denominator. And the same here. I want the f of 4 over x plus 1, so it's 2. So in the place of x, you put 4 over x plus 1, add on to 3. So notice I'm replacing the x right here with 4 over x plus 1. We multiply by 2 over 1, so that gives us 8 over x plus 1 plus 3. The common denominator is, there's only 1. The common denominator is x plus 1, so that's over 1, so we multiply by x plus 1 over x plus 1 to get the same denominator. So 8 over x plus 1, add on 3x plus 3 over x plus 1. We have a common denominator of x plus 1, we write it down, and we add 3x plus 11. Again, we're just subbing in this whatever is here in the place of x. So note, 1 over x is going into place of x, we're simplifying. 4 over x plus 1 is going into place of x, and we're simplifying. So right here, same thing. We're putting x minus 6 over x minus 3 into x. We're subbing it in right here with a bracket around it. So we multiply by 2 over 1. We get 2x minus 12 over x minus 3 plus 3. There's only one denominator, and it's x minus 3. So we multiply this denominator, this fraction, by x minus 3 over x minus 3. That gives us 2x minus 12 over x minus 3. Add on 3x minus 9 over x minus 3. Common denominator is x minus 3, so we add 5x minus 21 all over x minus 3. So again, just doing a little bit of function notation because you're going to need it later on. And find in simplest fractional form. Let's do another one. And if you want, you can pause your video and work these out. So the g of x is the same as f of x, same as the y, x squared minus 3x. Now I have to put 6 over x in place of each x. So notice I'm putting it in right here and right here. When I square it, I get 36 over x squared. And when I multiply by 3 over 1, I get 18 over x. The LCD is x squared, so I need to multiply this fraction by x over x. That gives me 36 over x squared, subtract 18x over x squared. Notice I got a negative, so I'm going to add on the opposite. So when common denominator is x squared, write it down, and add. So I get a negative 18x plus 36. I could take out the negative 18x, negative 18, and that'll give me x minus 2, but it won't cancel. So that fraction there, or this one, is the correct answer. And again, we're going to sub in 1 over x minus 1 in the place of x. and then we're going to simplify it. There we are. And so now we're going to square it. So 1 times 1 is 1, and x minus 1 times x minus 1 is x minus 1 squared. I didn't square that out. I left it because I got to leave it in this form because I need a LCD. So 3 over 1, negative 3 times 1 is 3, and x minus 1. Common denominator is x minus 1 squared, so I need an extra. Before I do that, let's add on the opposite. So I need an x minus 1 times an x minus 1. So that gives me 1 over x minus 1 squared. Add on negative 3x plus 3 over x minus 1 squared. Common denominator is x minus 1 squared. Add negative 3x plus 4, fully simplified. So notice we're subbing it into the place of x and simplifying it as a simple one. We want one fraction. And we're doing the same thing here. So the t of x is x plus 2 over x plus 4. So we're going to put 1 over 3x in the place of x. So 1 over 3x plus 2 all over 1 over 3x plus 4. So notice I'm putting 1 over 3x in the place of x. Now, we have an LCD, and the LCD is 3x. So because I have a complex fraction, one of the easier ways is to multiply all parts of the equation, top and bottom, by the LCD. So 3x times that, 3x times this part, 3x times this part, and 3x times this part. When we do that, the denominators will cancel. So 3x times 2 is 6x. 3x cancels, I get a 1, and that gives me a 12x. And if I want to write it in descending order, 6x plus 1 over 12x plus 1. And I cannot cancel in addition. So, functional notation. And a couple of more to do, the last ones. Number 4, we want, pause the video and work it out. The p of x is negative 6x. The h of x is 2x. So I have to put, this is the p, so I have to put 2 over x plus 3 in the place of that x. So I'm putting 2 over x plus 3 right there. So it's negative 6 times that. Add on h. So I have to put 5 over x squared minus 9 in the place of x right there. So that's the p of x. There it is. Plus, there's the plus sign. There's the plus sign. So I fill this in the p, fill this in the h. Now I simplify. We're multiplying by 6, so that's a negative 12 over x plus 3. Add on. Multiplying by 2. 2 times 5 is 10 over x squared minus 9. And so we factor our denominators to make sure we can find our LCD. So x squared minus 9 is x plus 3, x minus 3. So the LCD of this fraction is x plus 3, x minus 3. So that means I multiplied this fraction by x minus 3, top and bottom. Why? Because that will give me x plus 3, x minus 3 on the bottom, and it'll give me a negative 12x plus 36 in the numerator. This is already the LCD, so I don't change it. And when you add those, you get a negative 12x plus 46 all over the LCD. So it's simplified. Okay, number 5. F of x equals x over x plus 1. This is find x if the f of 1 over x equals 2. Let's see. The f of 1 over x. That means I have to put a 1 over x in the place of x. So the f of 1 over x, I have to put 1 over x here and here. There it is. Now, I'm going to simplify that. So the LCD is x. So I'm going to, because I got a complex fraction, I'm going to multiply all the parts by x. They cancel, they give me a 1. That cancels, that give me a 1. And 1 times x is x. So when I put the 1 over x in here, I will simplify that to 1 over 1 plus x. But the f of 1 over x is here and here. What we're saying is that 1 over 1 must be 2. Since the f of 1 over x simplified to 1 over 1 plus x, and the f of 1 over x equals 2, they must equal to each other. So cross multiply. If I want 1 equals 2 times 1 over x, because it's 1 times 1, 2 plus 2x, negative 2x equals 2 minus 1, because the x's swing to the left, numbers to the right. Negative 2x equals 1. Divide by negative 2, x becomes negative a half. X becomes a negative a half. So that's the value of x that will make this true. And just do x. So what we're saying is the f of x is x over x plus 1. So x is a negative a half. So if you put a negative a half in here, that's a negative a half all over negative a half plus 1. Multiply all parts by 2. 2's cancel. I get a negative 1. 2's cancel. I get a negative 1. 1 times 2 is 1. 2, sorry. That's a negative 1 over 1. So you get a negative 1. And that's true, but what is the f of 1 over x? So 1 over x is the reciprocal of a half, so that's negative 2. So if you put the f of negative 2 into this expression, right there, negative 2, you get a negative 2 over negative 1, which is 2. So a half will do it, because the reciprocal of a negative a half is negative 2. Negative 2 going in. That 2 is the same as that 2. So that takes us a little bit on function notation. That might be a little, number 5 might be a little bit confusing, but just check it out. If you like my video, click the like button, the subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.